Hey, good morning, afternoon, evening, whenever you're watching this, who knows. Hope you're enjoying your day. We're getting into 6.1 vectors in a plane, so find your green note sheet. We ready to go? Up top, definition of vectors. Used to represent quantities that have both magnitude and direction.
By the name of vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
All right, hope you're smiling now. That's probably the best part of the video. So a vector is a directed line segment with its tail at the origin and head at the point A, comma B. This is called standard form of a vector. We write it with V, we usually use V for vector, equals A comma B, so it looks like a coordinate, but instead of using parentheses, you can see we use those, kind of looks like less than and greater than symbols a little bit. But that's how you know it's a vector and not a coordinate. So a vector has magnitude and direction. So we can draw a vector, we start at the origin, we can go any direction we want. We always put arrows on the end of our vector. It doesn't mean it goes on forever like in geometry as a ray. It means it goes from the origin to that point, wherever that point is. So it has a horizontal component of A in this case and a vertical component of B. Holy cow, I'm writing neat today, aren't I? Alrighty, so that's component form where that A comma B. That's what we're looking at. Then we have a couple where we have magnitude. When we talk about the magnitude of a vector, that's the length of the vector. Hopefully you can already figure out how to find the length of that vector if you just look at it and think. The symbol for vector for magnitude is those, looks like almost parallel lines, and we name the vector V. So when we see that symbol right there, that means the magnitude of the vector. Direction of the vector is the angle that we're talking about. That's a unit circle angle. So we're from this x-axis, positive x-axis is 0, going in the direction like we're comfortable going, not like navigation. We're not quite as comfortable yet. Common names for vector, we usually start with vector V. Sometimes we use U, sometimes we use W. We can use any name we want, typically U, V, and W. Alrighty, now we're going to talk about the head minus tail rule. Any two arrows or vectors with the same length and point in the same direction represent the same vector. So we can tell if vector OP, let's put an O on that origin there. I think on the note sheet there is an O. We can find the length or the component form of OP, and then we can find the component form of RS, and we can see that they are the same. So we use OP as our symbol with a little kind of half ray up top, it looks like, sort of deal. Okay. So we're going to do the head minus tail rule. So the head is where the vector ends. So we're at that 3, 4. That's our head. So we're just going to take the horizontal component, which would be 3, and then subtract the horizontal component of O, which would be 0, because it's at the origin, the point 0, 0. Okay. And then we're going to do comma, 4 minus 0. And we're going to do that math. Hopefully we don't need a calculator for that. 3 comma 4. Then we're going to do the same for RS. So we're going to start at the head, which is at -1, 6. So we have -1 subtract the -4. Whoops, my bad. Comma 6 minus 2. We do that math, and we get 3, 4 again. So that proves that our two vectors are the same. They're just in different locations. So if we could take that vector RS and scoot it over right a little bit down, you would notice that it would line exactly up on the OP, and we have the same vector. Fantastic. All right. Now, what I want you to do is, now it's your turn, show that RS is equivalent to PQ. Okay, P being the tail, Q being the head. Go. Fantastic. You should have got 3, 4. 5 minus 2, 3 minus a negative 1. Great work. On to our next thing. Okay, so now we're going to do some operations with vectors. The first 3 here, the first 3 here make a whole lot of sense. So if I look at this one that says, suppose v is -2, 5, we can draw that. So horizontally we're going to go -2, left 2, and then we're going to go down, up 5, because that's positive. And then we're going to draw our vector. We're going to call that v. And then if I think about it, where would I think the opposite of v, or negative v, would be? What would you guess? Ah, that's a great guess. Exactly. The opposite of -2 is +2. The opposite of +5 is -5. So that one makes a whole lot of sense. A lot of times with vectors, these first couple operations, they just make a whole lot of sense. We're good to go. So the opposite of v, so then I put that in component form, which would be 2, -5. It has, I just heard some whispers, the same length, opposite directions from the boss lady. So notice they have the same magnitude, same length. They just go in opposite directions. All right, now it's your turn to do the next couple. They make a whole lot of sense, so your goal is to get through number 5 on your green sheet, and we will pick up there on Wednesday or notes. So you keep going, and the next operations, just like this one made sense, they make sense to you. What do you think would be nice? Go.
If you have questions, contact one of us or in class if you're watching this, and we'll answer your questions.
And have fun with it.